All right. Good morning or good afternoon, everyone. My name is Andrew Sartorelli. I'm the product manager here at nTop Platform, focused on some of our core capabilities. And today I'm going to be doing a bit of an introduction overview of some of the new latticing capabilities that we're going to be rolling out to everyone with our next release, nTop Platform 2.15, which comes out in approximately 2 weeks. And so just to talk a bit about some of the use cases we see with this new technology, I'm going to pull up one of my favorite models, which is this rocket nozzle example. Now, this rocket nozzle, if you've ever been to an nTopology event where we've been attending, say, a trade show like Formnext, may have seen this model. And it was quite a complex model to set up. And actually now, thanks to some of this new latticing technology that we're rolling out, to generate something like this, we see a nice conformal ribbing across the surface here with a grading in the height as well as the thickness of the struts. We've got now a conformal gyroid structure on the inside, as well as ribbing going on the internal surfaces here. All of this has been streamlined through our new latticing technology. We'll talk just a bit about how to access that. So coming with nTop Platform 2.15, you simply go to Settings, and under Settings, you'll see a new option called Show Beta Blocks. And when I tick this, we'll see a new toolkit come available in the Beta tab, and we'll see all of the new technology available to us through this new latticing pipeline. So let's talk a bit about some of the core features and functionality, and then dive into some of the more complex examples. If we go up here on the ribbon, we can see we have a new block. It's called periodic lattice body. It's periodic lattice body. It takes 3 inputs now to the process. And so we'll start with that first input to the process, which is a unit cell, which is a new object type that we've introduced in nTop Platform. And so this unit cell, in this case, we can see an example here of a gyroid. I can change through to some other triply periodic minimal surfaces, but it also extends to things like graph lattices that we're all very familiar with. So I can change through and go to some different unit cell types here. And with this preview option, I also will have the ability to look at an implicit view, so a 3-dimensional view of this object rather than the graph representation with 2-dimensional beams. So we've introduced the concept of unit cells that extends to both types of geometry, the graph geometry, as well as the implicit geometry with our gyroid-like structures. And the next step along with that is we've added the ability to import unit cell types from Element Pro, our previous product you may be familiar with from nTopology. So if you have an existing library of unit cells, you can bring those in using the new Import Element Pro. And that's going to act just like any unit cell that we generate within nTop Platform today. The other nice thing that we've done is we've added the ability to rotate unit cells. Now, in the case of this one, this fluorite, it's a more isotropic unit cell, but let's take a look at something that's a bit more anisotropic. So if we take a look at this column, right, we can see that it's oriented in a specific manner. And previously, if you wanted to change that orientation, it wasn't possible. Now through the orient unit cell block, I can go ahead and I can just change one of the cell orientations, and we'll see the orientation of the unit cell now is changing. And obviously, it's pretty clear from this case because we do have a very anisotropic unit cell. All right, if we go back and look again at the periodic lattice body, the next input into this process here is going to be something called a cell map. And so a cell map is just going to be taking some space and geometry and mapping that with cells that will fill with our lattice structure, our unit cell. And so we have, to start with, we're going to have 4 different cell map types. So the most common one that we have the rectangular cell map, which is going to take a volume, your cell size. So here, if I want to change my unit cell size, you can see it changes the size of this cell map. Also takes a frame. So if I want to change where this cell map is starting from, I can just move my frame a little bit, and we'll see updates the cell map that's generated here. So we have the standard rectangular map, but we also introduce a few new mapping types. So we have a cylindrical map as well. So if you want to map something to cylindrical coordinates, let's go ahead and maybe our frame here is off. So we're just going to set this back to 0, 0, 0. You can see that nicely fits within the region there. And the final mapping type we're introducing here for kind of traditional geometric entities is going to be a spherical map. So allowing you to map your lattice structure to a spherical domain. Okay, so these are the core cell map types and unit cells. This is really what goes into making a lattice structure map. So I'm going to go ahead and just expand this window here, and I've already gone ahead and created a few different lattice types. And so we took simply our unit cell, in this case the fluorite. We're taking a rectangular cell map, and then we're just passing in a variable thickness like we could before. And now we can see we have a nice graded structure here. And the nice part is, say I just want to swap out my unit cell, right? I can simply just delete my graph unit cell there, drag in my TPMS unit cell. Regardless of now what type of lattice I'm creating, I'm using the same technology, very easily transition between them as I generate the desired mappings. And so this works just the same for a cylindrical or spherical mapping. We're able to map any of the unit cells generated regardless of type to these new mapping styles. Right, and here we can see cylindrical. As we move through the ribbon, we also have a cell map on CAD face, and I'm going to talk a bit about this one and the last example of my session here today. But we're going to jump over next to a few of the changes to the lattice body from volume mesh and lattice body from surface mesh commands. So let's go ahead, and I'm going to take a look here. And I've got a nice little example on a cube, and then we'll jump into a larger example of this. So for those of you familiar with the lattice from volume mesh block previously, it would simply take the mesh edges and of a tetrahedral mesh and convert those to beams. But we've added a few additional options now. One of those options is the vertex centroid. So it's a bit of a different style of lattice structure generated here. We also support now the dual. Again, we can see a bit more of this structure. And the nice part with these lattice body from volume mesh blocks now is, if you want to, you can say, I don't want to include the surface. It's going to go ahead and regenerate that lattice. So say you already have a nice conformal lattice on the surface of the geometry and you need something to infill, you simply uncheck this include surface option, and it's going to go ahead and generate the structure only on the internal, and you can then merge that with a surface lattice. All right, let's go ahead, and I've got another example set up here. Let's go ahead and take a look. So I've got a nice car seat here, and I've gone ahead and I've generated a few different types of lattice structures for this. So the first one, I went ahead and generated a standard Voronoi structure. And so we can see that on the surface here. And we'll actually be adding, as part of this new pipeline, probably not in 2.15, but hopefully in 2.16, the ability to essentially normalize the distribution of cells in a volumetric Voronoi structure. So you get this nice uniform structure that you see here. Now, for those of you familiar with the Voronoi, you know it's a great way of filling a volume with a relatively conformal structure, as well as coming up with somewhat isotropic properties there because of the random nature of the Voronoi structure. And so the next option here is I've just gone ahead and I've generated a slightly different structure for my seat cushion. And I'm just using the vertex centroid option here to generate a nice little structure for my seat. And so we can see that just comes from a volume lattice that I've generated at the bottom. And then we're able to convert that using the vertex centroid option. Now I could take this a step further, maybe ramp some of the sizing of my elements, right? And end up with a more uniform sizing or a larger distribution maybe mapping. You've seen some of the examples from my colleagues using image maps or pressure maps to morph the structure, and we could do very much the same thing here with the seat cushion geometry. All right, so those are the kind of principal additions with the lattice body from mesh options. I'm going to go ahead and take a look at my favorite example now, which is this rocket nozzle. And so what we can do is we can go ahead and I'm going to start with importing this geometry, and I end up with a few different CAD bodies here. And I've already gone ahead and isolated out one of those, and that's going to be the face on the mid surface here. And I'm going to use this now to generate a conformal structure, generate some conformal ribbing. So previously, it wasn't possible to use gyroid structure on a conformal map. So let's go ahead and take a look at what that looks like. So I've already got my unit cell selected here. Let's just turn that on and take a look. We've got a nice little gyroid. And actually we can start playing with the thickness. So understanding a bit as we use thickness in our periodic lattice body, what is the impact on an individual unit cell? And we have this nice little slider here to understand that. All right, so we have our unit cell. Now we need to generate our map on our CAD surface here. So what we can use is we can go ahead and use the cell map on CAD face block. And what this takes now is just going to take a face. All right, and we're going to specify a UVW count. So we could do something like 20, 31. I'm going to say my offset in this case, well, I've already done this one. I'm going to go with minus 15 millimeters. And we're going to see now the cell map now, conformal map generated from the surface. We can see the preview of that map now here. And this is what we're going to use to apply our gyroid unit cell to. So I'm just going to delete this one. I've already got one set up here. And we can actually take a look now at this gyroid structure. And we could do a nice little render here if we wanted to see a bit higher resolution of what's going on. But we can clearly see now the gyroid structure conforming is exactly to our CAD surface. But if we think back to the example I was showing before, we have this nice kind of isogrid kind of structure, this ribbing structure along the surface here, and we can take a look at a few different attributes of that here. So the first thing that we notice is the height of the ribs is graded as I move upward. The thickness of the ribs also varies, right? We don't want the same thickness down at the bottom of the structure as we do at the neck of the nozzle, right? If we have a 3 millimeter thickness here, it's just going to be solid geometry within the neck, and we don't really want that. We want to continue to have ribs there, so we've got a nice grading of thickness there as well. And then as we move away from the neck, thickness increases again, as well as height. And so let's take a look at how we can do that, because now there's a few different options we have with the conformal map. All right, so if we go back and we look at our face here, let's go ahead and create a new map. So I'm going to go ahead and do my cell map on CAD face. Let's drag this down here. Again, using my mid face here, 20, 20, 31. And now there's a new option here. If we think about what we had for the conformal map before, we have this nice little icon here that says we can specify a field now for an offset, which is really powerful if we want to start grading this structure. So let's just start with the uniform one. So we're going to go with, let's do -5 millimeters. Generate our nice cell map there, and let's take a look at what happens. So we'll pop this cell map into the cell map fields here. I've got my unit cell, which is going to be a triangular honeycomb structure. And so that's what I'm going to use for my unit cell, and I'll drop that in. And let's just go ahead and do a uniform thickness, maybe 2 millimeters. All right. press I on my periodic lattice body to isolate that while we generate the view. Right, and if we jump back, let's just take a quick look. So the other thing I did in this example is I've gone ahead and set up a few planes here. So planes that we can clearly see the demarcation where we want to start transitioning from one level of thickness or height to another level. And so we're going to use that to actually create a transfer function. And I know, I think transfer functions are one of those things everyone gets a little bit scared by, but once you stop and think about it, they're actually quite easy and simple to use. All right, and so now we can see this structure, right? And exactly what I was talking about before, if we have uniform properties, uniform thickness, uniform offset, we end up with essentially solid geometry within the neck region rather than having distinct ribs, which is not what we want to have in this case. So let's go ahead and we're gonna delete this thickness. I'm gonna turn on my midface so we can take a look at it. And let's turn on my planes as well. I think those are going to be off to the other side here. Okay, so what we're going to want to do is we're going to start from the base and we're going to have a large thickness. So let's take a look at that transfer function that I've already gone ahead and created here. So what we're going to do is we're going to say my value, my function that I'm starting with, it's this base plane. I want to change everything based off the distance from the plane down here at the bottom. And I'm going to use the markers from the other planes to signify those different heights that I'm going to start modifying my values at. So if we look here, base plane, that's my first one. And at that first one, distance from that, it's going to be 0. So we're going to start with a thickness of 3 millimeters. As I move upward to my midpoint plane, kind of midpoint on the larger bell section of this, it's going to transition to a thickness of 2 millimeters. As I start to get closer to the neck, so the kind of the nozzle, the neck region here, it's going to be 1 millimeter, and then I'm going to keep a consistent 1 millimeter up through the end of the nozzle as well. So let's go ahead and we can drag this thickness function into the fields here. We're going to go ahead and regenerate that lattice structure. Now, this will be great for modifying the thickness of the individual ribs, but actually I want to start modifying the height of those as well. And so this is why we have another transfer function. So actually we can see this looks fairly decent. We still get a little bit there, maybe a bit too much. And it's a uniform height across the entire structure. And we want to introduce some grading, which wasn't possible before. So let's go ahead and I'm going to take a look at this sizing function, as I called it here. And what I'm going to do is I'm going to press F, and we're going to take a look at Field Viewer. I'm just going to trim this down to about 400. We're going to look at it plane normal on the Y. Actually, let's do X. And I'll change my color to Turbo, a great new color map option that we added last release. Gives you a bit more of a consistent perception across the entire color map rather than the previous one. You could see kind of stratification there. And so let's look at this sizing function now, which takes the same planes we were using before and now just varies the offsets. And if I use my probe values option, I can see my offset here as I'm down here up until that midpoint is going to be -1 millimeter. As I start to transition up further and further, we can see that value changing and becomes a consistent -3 millimeters up through the top of the nozzle. So let's go ahead and we're going to drag that sizing function block just right into the offset fields. And now it's going to go ahead and update that entire structure. And we'll take a look after it generates at the structure itself, as well as the cell map, and examine how that varies. It does look like we have a question here. I'm just going to take a quick look. Within the cell map, can you show us toggle of the offset from minus to positive values? Sure. Okay. We'll take a quick look at that in just a moment. So in this case now, we can kind of see the structure, the offset down at the bottom, it's very low, right? -1 millimeter. As we get closer to the top, -3 millimeters. So let's go ahead and take a look at this cell map in particular. I think it really shows the variation here. So we can see the offset of the structure, -1 millimeter here. As we move up through the structure, we can see the cell map size is increasing in thickness. And so the question was, what happens if I change it from positive to negative? Let's go ahead and take a quick look at that. So I'm just going to go ahead and create another cell map on CAD face. We'll drag in our mid surface, 20, 31. And what is my offset going to be? So instead of a negative value, let's do a positive value. We're actually going to see this one go into the object. So let's turn that one off. All right, and if I turn on my face, right, we can see now our cell map is going into this object in this case. So depending on the CAD geometry that you're starting with, maybe a positive offset, maybe a negative offset, just a simple value you have to tweak there. Okay. And so the last piece of functionality, I don't want to go through this entire example here. We're going to provide everyone with the sample files after the webinar that you'll be able to use with nTop Platform 2.5. There is one more feature I just want to talk about, and that's going to be our new remove beam options, which is a really common feature request. And so let's go ahead and take a look at it with this seat cushion example. Okay, so what I'm going to use is this new remove beams and faces block. And what we do is we specify a lattice, and then we specify a filter that we want to use. So in this case, we have filters for length and angle, and we're planning to add additional filters here in the coming days. So let's go ahead and I'm going to use filter by angle. Let's drop it into my filter field there. And I'm going to say that if I have an angle greater than, let's say, 45 degrees with respect to a frame that's on the horizontal here, that I want to start removing beams. Okay, and so let's give it a second to go through and remove all of those beams there. But essentially what this allows you to do is, remove small beams that may not be manufacturable, remove beams based on the overhang angle if you feel that those aren't suitable for the manufacturing process. Gives you a lot of flexibility in the control of your structure. And that's one of our real goals, is to give folks the ultimate control to design without boundaries these structures, whether they're graph-based lattices, gyroid-based structures, really driving them to the extreme. All right, and now we can go ahead and just take a look at what we've done here in terms of removing beams. And we can see removing a lot of different beams from the surface here that we're having an angle greater than 45 with respect to our plane there. So I want to thank everyone for attending this session this morning, and I hope everyone enjoys the new Lattice pipeline that will be rolling out with nTop Platform 2.15, which should be approximately 2 weeks. And again, remember, as you get this new version of the software, to gain access to this, simply go to Settings and Show Beta Blocks. Thanks again, everyone. Take care.